Hello, and welcome to GP Podcast. Today, we're diving into something Microsoft just released that feels, well, it feels different. This isn't just another chatbot. This is an explainer about an AI that's designed not to generate content, but to generate decisions, optimal ones. So, let me start with a question for you. What's the biggest problem in AI that you've probably never even heard of? See, it's not about making models bigger or faster. No, this is a hidden problem, a quiet bottleneck that has been slowing down entire global industries for decades. Okay, let's get into this. You see, the real engine that powers these massive decisions in logistics, manufacturing, supply chains, it's not actually AI. It's pure math. We're talking about mathematical optimization solvers. These are incredibly powerful tools that tell giant corporations the single best way to route their shipments or schedule their production to save millions. They are amazing at finding the perfect answer, but they have a serious weakness. And this slide right here says it all. The solver, the math part, it's not the problem. The real bottleneck is the human translator. It's that highly specialized, very expensive expert who has to take a messy, real-world business problem and painstakingly turn it into the perfect, clean, mathematical language that the solver can actually understand. For years, this has been the standard way of doing things. You've got a business problem. A human expert then spends days, sometimes even weeks, translating it. And only then can the math solver do its magic. That second step, the human translation, that is the exact point where global efficiency just hits a brick wall. It's slow, it's manual, and it has created this huge backlog of optimization problems that could be solved if only we had a better way to describe them to the machine. You see, the crucial point here is that these solvers, they don't speak English. They speak the language of mixed integer linear programs, or MILPs for short. This is the very specific, very rigid format. You have to define all your decision variables, all your constraints, all your objectives that a business problem has to be converted into. And it's incredibly complex. If you get it even slightly wrong, the answer you get back is just garbage. So Microsoft took a hard look at this decades-old bottleneck and basically asked, wait a minute, why are we still doing this by hand? And their answer is a brand new model they're calling Optim. They're framing it as the missing bridge, the AI that finally connects our human, natural language way of describing a problem directly to the raw number-crunching power of those math solvers. And what Optim actually does is, frankly, revolutionary. You describe your ridiculously complex decision problem in plain English. Optim then handles the entire translation process, all on its own. It doesn't just spit out the math, it generates a complete, ready-to-run Python script that defines the variables, sets the constraints, calls the solver, and then prints out the optimal decision. It automates that entire human bottleneck we were talking about. So the question is, how on earth did Microsoft build an AI smart enough to do a job that, until now, was pretty much reserved for people with PhDs? To find out, we're going to have to go inside the engine room. Okay, so under the hood, Optimus is a 20 billion parameter model, but it uses a mixture of experts architecture, which makes it super efficient. It also has this massive 128,000 token context window, which is absolutely crucial for handling those long, really detailed business problems. And here's the real kicker. Microsoft released it under an MIT license. It's truly open source, so anyone can use it or build on top of it. But here's the thing. Building this wasn't just about throwing a giant model at the problem. The real secret to Optimus' success, the reason it got so good at this very specific, very difficult task, it wasn't just about having more data. It was all about having smarter data. And this, for me, is the most fascinating part of the story. To teach this AI, Microsoft didn't just rely on a bunch of programmers. They brought in actual optimization experts. They used real human intelligence to guide the artificial intelligence. They came up with this really clever process called class-based analysis. So first, they categorized all these different optimization problems into 53 distinct types. Then, they looked at where the base AI model was consistently failing for each of those types. After that, the human experts actually wrote down hints. You can think of them like cheat sheets, explaining the common mistakes and how to avoid them. And finally, they used those expert hints to automatically clean and correct their entire training dataset. They basically taught the AI to think like an expert, right from the ground up. So the theory is pretty brilliant, right? But does it actually work? Let's take a look at how Optim really performed when they put it to the test, and just as important, what its creators are cautioning us about. The hero number you need to know is 20.7%. That is the direct improvement in getting the mathematical formulation right that Optim achieved compared to its already powerful base model. That's a huge leap, and it really shows that their whole expert-guided training process paid off big time. But to their credit, Microsoft is also being very realistic about this technology. On the one hand, yeah, it's excellent for research, for prototyping, and even for teaching people how to model these problems. But on the other hand, they are crystal clear that human oversight is absolutely essential for any kind of serious application, especially in high-stakes areas like finance or safety. In fact, they lay out several really important warnings. The model can still make mistakes. It absolutely requires a human in the loop to check its work. Any code it generates has to be run in a secure sandbox environment first, and it is definitely not intended for any kind of safety-critical or regulated industry right now. It's a powerful tool, not some magic oracle. All right, so let's zoom out. What does all of this really mean? Beyond the tech specs and the percentages, why does a tool like Optim actually matter for the future of business and technology? I think the big takeaway is this. This is about democratizing high-level decision-making. If Optim and tools like it continue to improve, it means that optimization, the science of making the absolute best possible choice, will no longer be locked away, accessible only to a small handful of expensive experts. Any team, as long as they understand their own business problem, could soon have the power to find the mathematically optimal solution. And that brings us to one last kind of provocative thought. We've seen AI learn to generate text, then images, then code. Now we're seeing it generate optimal decisions for incredibly complex business operations. So the question we're all left with is, what will it optimize next? If you liked the video, subscribe, leave a like, comment on what you liked most, and share the video.